Topic 3.1, graphing linear equations. First, we're going to start off with the concept of a slope. A slope measures for a line the rise and the run. The abbreviation for slope will be the letter M, or the symbol for slope will be the letter N. Okay, I want to give you 3 examples of slope and show you how they work. Let's say a slope of 4/3, a slope of -2/5, and a slope of 3. Okay, again, the slope tells you the direction that a line is headed in. So let's start off, you have to start off with a point, so you have to give a point. And from here, I'm going to run 3 times and rise 4 from that point. So run 3 times and rise 4 gives me a second point. And this tells me the direction of my line. Okay, now for lines, the slopes are consistent. So if you use the slope again, you'll get yet another line. So I'm going to run 3 times from this last point, and I'm going to rise 4. And that's how you get additional points, by using the slope to run and rise. Next, how to handle negatives. Negatives I usually associate with the numerator. So I'm going to run 5, but fall 2. Run 5, but fall 2. And all these points, kind of missed it. All these points will be along the same line. Okay. Now, how to handle single digits. Slopes, again, are made out of 2 numbers, a rise and a run. And here, 3 is a single digit. Whenever you have single digits, treat the run as 1. Treat the run as 1. So, from this point, let's lower that a little bit. So, from this given point, I'm going to run 1, but rise 3. Run 1, but rise 3. Okay. Now, let's look at some special slopes. And this time, instead of giving you the slope first, I'm going to give you the line that it makes first, and then we'll figure out what the slope has to be. First type will be the horizontal line. And then we're going to look at the vertical line. Okay, let's put points along the horizontal line. All right, for a horizontal line, you can see the run from one point to another point, let's say it's about 4. But to go from one point to any other point, there is no rise. So the rise is always going to be 0. Again, because the horizontal line never rises but only runs, its numerator will be 0. Therefore, the slope for a horizontal line will always be 0. Now for a vertical line, we see that from one point to the next point, we have rise. Here we have about a rise of 3. But vertical lines never run. They only rise. So their runs will be 0. And since vertical lines never run but only rise, their slopes will always end up being undefined. So these are special slopes. So when you have a slope of 0, you know that you're dealing with a horizontal line. When you have an undefined slope, you know you're dealing with a vertical line. Okay. Next, the slope formula. The slope formula is made out of the y's in order to get the rise. You take the y's from the points. Points have x's and y coordinates. So you take the y coordinates from two points and you subtract them. This is actually an additive inverse. It means change the sign instead of subtraction. So you change the sign of one of them and they combine them and you get your rise. For the run, you put your x coordinates in the same order, change the sign of the second one, and combine them, and now you have the run. Order does not matter as long as you use the same order. So you can use the first y and the second y. You have to use the first x and then the second x. So the order is important, but it doesn't matter which one you use first as long as you use the same one first in the denominator. Okay, so let's do some examples of slope. Let's say we have a point of -4, -1, 3, -3. And let's put another example here of -5, -1, and -3 and 4. Okay, so to get the rise of a slope, we use the y's. Okay, one y will stay the same, the other one will be changed. That's what the negative means. It means additive inverse or change. So what I'm going to do, I'm going to use this one. I'm going to keep this y right here, the -3, and this is the one I'm going to change. So keep -3, but change this to +1. Keep the -3, change to +1. Keep, change. For the x's that will create my run, I'm going to use the same pattern. This x will be the one I keep, but this x will be the one that I change. So I'll keep 3 and change to +4. So now I have a -3 or +1, which is 2, and 3 + 4, which is 7. So the slope for this is 2 7ths. It means that it's running 7 times and then rising 2, running 7 times and then rising only 2. Next, the slope for these two would be, let's see here. Oh, I'm sorry. I have a -3 and a +1, so that'll be a -2. So I'll put my negative right there. All right, let's change that. Okay, so this is actually going to go, it's going to run 7 and then down to run 7 times and then fall down twice. Okay, got that -3 and +1 should be negative. All right, next one. My rise will be made out of my x's, sorry, my y's, and my y's are -1 and 4. I'm going to keep the -1 but change the 4 to a negative. So keep the -1 but change the 4 to a negative. So keep and change. And then for the x's, which will be my run, I'm going to keep the -5 but change the -3. So keep the -5 and then change the -3 to a +3. This combination gives me -5 in the numerator and a -2 in the denominator. The two negatives, they'll cancel out and become positive. And what I have is 5/2. So this line is going to run twice but rise 5 times. Run twice but rise 5 times. Okay. All right. That takes us into linear equations themselves. Okay, now when we graph linear equations, we use generally two forms. The first form is called the slope-intercept form. Which looks like this. Y will be by itself, a number in front of x, then plus a number at the end. The second form is the general form. The general form has the x and the y's on the same side. And then finally a number equal to a number at the end. Okay, now let's look at graphing this guy. let's say we have y equals 2x minus 5. And let's also do a second one. Y equals negative 3/2 x plus 4. Okay. First, we start off with this right here. This is my y-intercept, 0, negative 5. So I start here. This negative 5 is actually the y-intercept. That's why it's called slope-intercept form. 0, negative 5 is located right here. So that's step 1. Step 2 is to move here, my slope. My slope is 2, or should I say 2 over 1 from here. So this will take me to my next point. To get to my next point, I have to run over 1, but then rise 2. So I run 1 time, but then I rise 2. And it takes me to this point right here. This point, because I ran over 1, is 1. And I rose up 2, y would be negative 3. Again, I'm going to run 1, and then rise 2 times. This next point, because I ran over 1, it's going to be 2, and because I rose 2 times, I'll be up to negative 1. And that's my line. Okay, next one. Slope-intercept form. First we start off with this. This is my y-intercept, which will be 0, 4. So 1, 2, 3, 4. Okay, that's your first point. Now to get your other points, we're going to use the slope. Slope will be negative 3 over 2, which means I'm going to run twice but fall 3 times. Run twice but then fall 3 times. That new point, because I ran twice and I was at 0, will be 2. But I fell 3 times, so I went from 4 down to 1. So that point is 2, 1. I'm going to run over twice again and then fall down 1, 2, 3 times. Okay, that point there, because I ran over 2 more times, will be x is 4, and I fell down 3 times, y will be negative 2. And that's the graph for that. Okay, now let's look at general form. General form, I have x plus y equals negative 5. And let's also write 4x minus 5y equals 20. Okay, for general form, we tend to go for the x and y intercepts first. So the x intercept we find by making y 0. So this will be x plus 0 equals negative 5. And so x will equal negative 5. So the x-intercept will be negative 5 for x and 0 for y. And so 1, 2, 3, 4, 5. So that's my negative 5, 0. For the y-intercept, we make x 0. And we end up with y equals negative 5. And so that point will be 0, negative 5 for the y-intercept, which will be 1, 2, 3, 4, 5, located right here. And now we have 2 points, and we just simply draw a line through them. Okay. All right, number 4. Same idea. For the x-intercept, I'm going to make y 0, so I'll get 4x minus 0 equals 20. 4x equals 20. X will equal 5. And so 5, 0, that will be my x-intercept. That's located here. 1, 2, 3, 4, 5. Next, I'll go for my y-intercept. For my y-intercept, I make the x 0. So 0 minus 5y equals 20. So negative 5y equals 20. We divide everything by negative 5, and y equals negative 4. So 0 and negative 4 would be the y-intercept. So 1, 2, 3, 4. And we have 2 points, so we can create our line. Okay. All right, those are the handling the slope, intercept in a general form. Now let's look at some special lines. Okay, the special lines will be the horizontal and the vertical line. Okay, the horizontal line is always written as y equals a number. Always written as y equals a number. Whereas the vertical line is always written as x equals a number. Okay. In fact, I want the b over here. Y equals a number and b equals a number. Let's see what I have written here. Yeah. Okay. So, for example, let's say we had y equals 4. Well, again, we're dealing with a special line. Y is by itself. Therefore, we're dealing with a horizontal line. So we go to the y-axis and go to 4 right here, and we create a horizontal line. Now, to find points along that horizontal line, know that all the y's are going to be 4. So we choose points. Let's say a point here. That's 0, 4. A point here. Let's say that's 5, 4. And let's say a point back here. That could be negative 2, 4. When you choose points along the line, make sure the y value is always 4. Now, let's do another one. Y equals negative 3. Okay. Again, this is a special line. Y equals negative 3 will be horizontal. So we go along the y-axis and we go to negative 3. Create our horizontal line. And if we want points, we make sure that the y value is always going to be 3. So this will be, let's say, 2, 3. And this right here could be negative 2, 3. So creating points is not that hard. And once you memorize that y's are special lines that are horizontal, you can draw these pretty quickly. Now let's deal with special lines that are vertical, which is x equals a number. Let's say we have x equals 5. And here we'll have x equals negative 3. Yeah, negative 3. Let's get this out of the way. Alright. First idea is that x equals 5 is a special line, which is vertical. So we're going to go to the x-axis, go to 5, and create a vertical line. And that's pretty much it, how to graph it. Now, how do you get points along that line? Points along that line will always have 5 as the x value. So this could be like 5, 4. This is 5, 0. And this, let's say, is 5, negative 2. Okay. Now, let's do another one. X equals negative 3. X equals negative 3 is a special vertical line. So we'll go to negative 3 here, make a vertical line along the x-axis. Oh. And that's our line. Now, to create points, you just simply make sure your x value is -3. So let's say that's -3 and 4. And let's say that's -3 and a 2. So creating points, just a matter of making sure that the x value is -3. Okay. Now, let's talk about the point-slope formula. The purpose of the point-slope formula, which is y minus y1 equals m x1, x minus x1. The purpose of the point-slope formula is to take a point and a slope, put it inside this equation right here, and eventually it's going to develop a linear equation, y equals mx plus b. So again, the idea here is to take a point and a slope and be able to develop a y equals mx plus b, that's slope-intercept form, or you can develop general form. So, let's take a look at that. Let's say we have the points 3, 1, and the point -6, -5. And we want to make a line out of this. Well, the formula here says we need a point, so we do have a point right there. But we also need a slope. There is no slope there. So I'm going to go back and use my slope formula to develop the slope, and then I can use my point-slope formula. So first, using the slope formula, which is y2 minus y1 over x2 minus x1. This, I use my y's for my numerator, so I'm going to keep the 1 and change the -5. Keep the 1 and change the -5 to a +5. Then for my x's, I'm going to keep the 3 but change the sign of the -6. So 3 +6. This gives me 6 over 9, which gives me 2/3. So I have a slope of 2/3. And I have 2 points to use. I'm going to use this first point, 3, 1. Okay, and let's put it inside the formula. Y opposite of y, m x minus 1. Okay, this stays the constant y. The opposite of y will be a -1. The slope will be 2/3. Here's the x. The opposite of x is right here, which will be a -3. Now, I'm going to distribute my 2/3. So 2/3 times x gives me 2/3 x. And my 2/3 times -3 gives me a -2. Yep. Then I'm going to add 1 to both sides. And I get y equals 2/3 x minus 1. And this is my linear equation derived from 2 points. Okay, let's do that again. -1, 9, and 2, -3. 2 points. We want to find out what's the equation of the line that goes through those 2 points. Well, I'm going to need my slope first in order to use my point-slope formula. So, I'll use this as my unchanged y, this will be my changed y. So 9, and change -3 to +3. Then for my x's, I'll keep my -1 and change this +2 into a -2. This gives me a 12 over -3. And a 12 over -3 ends up being -4. Now, we pull out the point-slope formula. And from here, we get the opposite of y. Let's use these two right here. The opposite of y would be a -9. The slope will be a -4. The opposite of x will be a +1. And And now I'll distribute my negative 4. So I'll get negative 4x and a negative 4. Add 9 to both sides. I get y equals negative 4x plus 5. And this is my linear equation that goes through these 2 points. Alright, number 3. This time for our points, let's choose 3, 1, and 1 and 11 thirds. Okay, just to make things a little interesting. Alright, first we need to find our slope in order to use the point-slope formula. So slope will be made out of my y's. I'm going to use this as my first y, and this will be my second y. So this will go unchanged, the 11 over 3. This positive one will change to negative 1. This x here will remain 1, and this x here will change from positive 3 to negative 3. Okay, and you notice we have a fraction within the fraction. This is called a complex fraction, and the way that we get rid of the complex part of the fraction is to multiply the numerator and denominator by the least common denominator, or the LCD. So the LCD will be 3, because the denominator is 3, 1, 1, and 1. So I'll multiply everything by 3 from top and bottom. And this will give me now a 33 over 3, which is 11. 3 times negative 1 is negative 3. 3 times 1 is 3. And 3 times negative 3 is negative 9. And now when I put these together, 11 and 3, this gives me 8. Negative 3 and a negative 9 gives me negative 6, which ends up giving me 4, negative 4 thirds. Alright, so that's my slope, negative 4 thirds. Then we're going to use our point slope formula. Okay, and again, we are replacing these 3 right here, those 3 numbers. So y, the opposite of y would be negative 1, the slope, negative 4 thirds, and the opposite of x would be negative 3. Okay. Let's distribute my negative 4, so we'll get negative 4 thirds x. Distribute my negative 4 thirds, 2 negatives will give me positive, and I end up with 4. And I'll add 1 to both sides. I end up with y equals negative 4 thirds x plus 5. And that's my linear equation that goes through these 2 points. Okay, number 4. My points will be 6, negative 3, and 1, comma, 11 over 3. So we'll try the fraction again. Alright, in fact, this time, let's... we'll go ahead and work with that. But I'm thinking about going into general form this time, just kind of show you what general form looks like. Okay, so my slope will be made out of, this is my y, so 11 over 3. The opposite of this y, which is positive 3. This is my x. The opposite of this x would be negative 6. Because I have the fraction in here, I'm going to multiply everything by the least common denominator, or the numerator by the least common denominator and the denominator. And this will give me, in the result, 3 times the 11 over 3 will be 11. 3 times 3 will be 9. 3 times 1 would be 3, and 3 times negative 6 would be negative 18. Okay. And that'll give me 20 over negative 15. And that will simplify down. 5 goes into 20 4 times, and 5 goes into 15 3 times. So I get a negative 4/3 again. All right. So y minus y1 equals mx minus x1. Okay, y, and we'll replace the opposite of y with a positive 3. The slope will be negative 4/3, and the opposite of x will be a negative 6. Okay. Now, from here, I want my x's and y's on the same side. Also, I don't want any fractions, so I'm going to multiply the whole thing by 3. Let's put a big bracket here. What the 3 is doing is multiplying and getting rid of that fraction right in front. So what we'll have is a 3y plus a 9, a negative 4 times an x minus 6. Then I'm going to distribute my negative 4. Negative 4x plus 24. Okay. And you notice again we don't have the negative there, which is great. Sorry, we don't have the fraction there, which is great for multiplication. Now I'm going to pull my x's on this side, and I'm going to put my 9 on the other side. So positive 4x with the 3y, negative 9 together with the 24. So I end up with 4x plus 3y, and this is going to be a 15 on that side. And this is general form.